Alrighty. Hi, everyone. My name is Matt Puchalski. I am the founder and CEO of Bucket Robotics. We are a Y Combinator-backed startup that focuses on defect detection for manufacturing of injection molded, cast, and machine parts. And what I want to talk to you today is how to successfully scale your synthetic data pipeline, and really focusing on our something that I spend a lot of time thinking about, which is taking the CAD model of parts that you care about and leveraging that to develop a really excellent computer vision product. This is, sort of the problem that is upstream of all of the amazing tooling from the 51 project, right? Of how do you actually generate data, which is a real problem in computer vision. So, So yeah, why are we here? What are we talking about? What's going on? Um, so as we all know, we're computer vision maniacs, and one of the big problems that we see with computer vision is you're only as good as the amount of data that you have access to, and how quickly you can, actually retune your process. I remember back in, ye olden days when I was starting with computer vision, it was incredibly manual and incredibly slow for collecting real world samples and hand labeling things, before the days of auto labeling, before the days of, even import OpenCV, right? Um, and the problem with industrial AI applications is that is the world that a lot of our end customers are living in, right? And so, how do you take the incredible advances that we have available to us with synthetic data to bridge this sort of gap, right? Um, so it is incredibly, deeply difficult, and I'll get into this later. Working in the industrial space and building a bad sim pipeline. So there's some tricks that we can talk about, but some of the highlights that I want to go through here are, let's talk about what synthetic data allows you to do that real world samples can't. Why real world collections are kind of a rabbit hole if you're actually building and deploying vision models onto factory floors, plural. And what are some real insights that we can collect from end customers that, we as engineers might not think of as computer vision assets? So that's sort of the high level. Let's flip over to how our customers think about this problem of synthetic data. Um, and the answer is customers don't think about synthetic data. What do they think about? They think about the cost of manual inspection, right? We as a human species have this 80% limit of how good a human being is at any monotonous task. That has been studied since like World War One kind of thing. And so when you're asking a human being to visually inspect something again and again and again in this very I Love Lucy type situation, it's horrible. The end operators know it, the line managers know it. But the problem is there's a bottleneck to deploying a robot there, right? That variable lighting is a huge pain in the butt, right? Maybe that throughput is really, it's an incredibly high throughput line. And so, end customers are thinking in terms of compute from a decade ago, whereas now you can import OpenCV and grab a Raspberry Pi and you'd be already there. But there is this trust gap that we need to bridge, right? Um, when you go to some really advanced facilities, and you start to talk to people who are familiar with computer vision and are on the quality inspection teams. They're thinking in terms of golden samples, which is still good and it's really excellent, but there is no better golden sample than your dimensional CAD files, right? Um, all of this being said, you can have the world's best sim engine. You can have the world's cheapest sim engine. You can have the world's fastest sim engine. Nobody cares unless you can actually prove that you are saving the customer time and money and building confidence, right? That's what everything is all about in manufacturing. Whoop. So, what even is synthetic data, right? Our synthetic data that we're referring to in the industrials space is a digital representation of a component that we can use as part of a robotics pipeline, right? So, what we at Bucket really focus on, and what I think a lot of you are really interested in, is synthetically generating samples of actual components, actual parts, actual tangible things. Um, and so, when we're looking at this synthetic data, we want to achieve photorealism that we can also, have labeled because we are simulating these parts. You can build your labels for free, right? Um, and the way that we sort of tell our customers about this, it's like having a flight simulator, right? It's a model where you have the sky's the limit on your variations and what you can do with this. Um, and so it's images that we have here to our right, these all came from our bucket system. I've used these examples on our YouTube page before, and what we're really showing off are the three different ways that synthetic data is great for being in a manufacturing setting by, say, simulating, what would take you thousands of hours to find enough real world samples. That's seconds to generate different defect types. Our door handle case there, we're showing all the different lighting variations that you can go through. And the gear, another big problem that exists in manufacturing is being able to switch between colorways or materials. All of these are different concerns for industrial customers that spending the time investing in a really good quality synthetic data engine makes your life as the computer vision team much, much better. So, why, this is a really great moment to be thinking about synthetic data in the industrial space. Um, I have spent quite a bit of time in robotics. So I started as a robotics integration person at Michelin, the tire company down in Greenville, South Carolina. And then from 2018 to last year, I was an integration engineer at Uber, then Argo, then Latitude, then Stack AV. And so I've sort of seen the practical deployed robotics and also the real fun that comes from having billions of dollars at your disposal, like in the self-driving car industry, and very, very strict criteria of you need to invest in a simulation to make sure that you don't have an incident on the road. Um, Moving into the industrial space, it's a mix of both, right? There's no baby strollers or uh, like snow in your end customer facility, but you do still have a strong need for really, really high levels of nine accuracy. So what I'm trying to say is, through the powers of self-driving and like VC dollars, um, the free market has really brought up the hardware and the tooling, the tooling infrastructure to be able to build a good synthetic data engine. Um, I think the first robot car that I worked on had less compute than split across like six different computers in the trunk, than what you could buy available on Amazon from NVIDIA. And it's already automotive rated, right? It's absolutely incredible what you can do with something like a Jetson or a Nano or yeah, any we can go into some of the hardware that I like using. But with the advances that self-driving has brought, it's also given us highly performant and quantized models that need more and more data so that way you can actually deliver your accuracies. So that's sort of the fun balance that we're at where we go back to synthetic data being really important. Um, the other things that are great are some of the advances in the last like 5 years, really since COVID. The Blender and Unreal Engine community has really taken off, and I don't see talked enough about in um, applied robotics. It's truly, truly incredible. We can thank the community of folks who are really into sim racing to do some really amazing work at really creating hyper realistic models of plastics and carbon fiber that's available online, which is really quite cool. So, what you're actually here for, what you're really excited about. Let's actually talk through and at a very, very high level, go through every single item of how to build a synthetic data pipeline from a CAD file, right? So when we say CAD file, we're talking about a dimensional file. This is something that you'll see from, CATIA or SolidWorks, anything where you're outputting a dimensional file that you can output from STEP. This is a great baseline when you're deploying in manufacturing because almost by definition of whatever your end customer is manufacturing, they have that dimensional file available. Um, so moving to our next point, that's where the fun really starts, which is how do you actually take that step file and convert your digital representation into something that is a deformable object. Depending on how you're doing this, you can either hand roll your own or you can go to something like Open Cascade. There's a few different ways of doing this. All are painful, but worth it. Um, and then, we're once you have a deformable object, and you have the ability you've identified whatever engine you're actually going to be doing, whether you're using NVIDIA's Omniverse or Blender or maybe Unreal Engine, or your own thing. There's a lot of different engine options. I really, really want to focus on what makes a good synthetic data set go from good to excellent, and that is investment in your levels of detailing for your lighting variations, your surface textures and finishings, and your background clutter itself. Um, one of my favorite like things to ask folks who have deployed computer vision models in manufacturing is to ask, when you were testing, did you ever account for the glare that you see from a safety vest? And some of my absolute favorite folks have that like 1,000 yard stare of, oh gosh, yeah, that reflection that you get from a high vis vest. We never accounted for that when we were building our data set, and then it goes to deploy, and your boss is standing next to the line, you're showing off, and then your model goes to hell, right? By building a synthetic pipeline, you can actually account for those lighting variations. It doesn't need to be all the time, but it's easy to think of early and then go from there, right? And it's all of these sort of micro decisions that build on top of each other, build on top of each other, and build on top of each other that gives you a really high quality data set. Um, and then from there, you are, really to the right of this talk, but then it's just all the fun other decisions that you have to make, which is, okay, great. If I'm building up this high volume of data, what is the bookkeeping that I'm doing to actually, decide how we are going to use this in our vision application? Are we, using something that is built on YOLO, where my formatting matters a whole bunch or not. Um, what is the size of the image that I even actually care about, right? I can have an infinitely perfect sim engine, but if I am running my vision model on a potato, um, do I need to export like multi-gig images? Right? These are the knobs that we need to tune for that are always always in the back of the mind of somebody who is actually building the data set pipeline, and almost never in the mind of the data analytics or end applications computer vision team, right? The answer is always shrug emoji, give me more, please. I'll always take more, right? And as the person responsible for building your sim engine, it's being able to sort of walk that line back and forth. That's the way to really think about this and deliver a good product to your internal customer and then eventually to your industrial customer themselves, right? So, um, like I said, in industrials, you always run the risk of, well, really in anything when you're developing a synthetic pipeline, you always run the risk of having unrealistic data. And that's a huge problem in your synthetic, well, really in any computer vision application that's applied, right? When you build from your CAD renderings, you always have to remember that your CAD is, the absolute perfect. And so one of the things that we've spent a lot of time doing at Bucket Robotics is understanding, and really building out your tooling for, okay, that's your absolute perfect. But if we look at any injection molded component anywhere on planet Earth, and compare it to what the perfect means, we'd never sell anything. So what is good enough? It's building in that concept of good enough, starting at your data set, leads to a much, much better product, right? Um, and so again, the other thing that leads to that is that's at the actual component level. Abstracting that a little further and going back to the previous slide, um, how do we develop a good uh, representative data set that is at understanding each line has different lighting conditions, each component has different lighting conditions. The angles at which you're actually viewing these and doing that sim to real transfer is deeply, deeply important. So if you haven't accounted for that inside of your synthetic data engine, then you're host, right? These are all of the problems that you have to juggle. And a lot of that comes from testing, a lot of that comes from talking to customers, and a lot of that comes from just deep uh, anxiety, right? And again, I go back to that 1,000-yard stare of having done things before. Um, Nothing hurts harder than, I think back to when I was building the robot cars, and you spend so much time building an HD map of a city in winter, because that's when it's winter break, and so there's no buses on the road and nobody's on the road and it hasn't snowed yet, so you collect a bunch of data, and then spring comes and the trees blossom and all of your cars freak out because there's all this extra, there's all this new vegetation that didn't exist in the middle of December. That problem is as true for building, robust vision systems for self-driving cars as it is in manufacturing environments. It's thinking about um, what is your springtime event for whatever your end application is. That's always fun. So, not to turn this into a sales call, but how do we do that? Well, as I've said, this is what we think about every single day at Bucket Robotics. Um, so one of the big things that I like about our approach is I have really focused on being able to build a synthetic data set in a CPU bound environment. This is something that comes up a lot, which is again, an Omniverse is an incredible product, but there are still huge amounts of end customers that want to be able to generate their own data set where GPUs aren't an option, right? Um, so with a CPU bound environment, we're able to go from that step file, convert it to deformable bodies, and generate tens of thousands of images in hours. To the computer vision ear, that sounds like an eternity, but when we're talking to customers who have, weeks long lead time or mold in the injection molding case, um, that means that you have a huge data set of knowing exactly what is good or bad before you've even manufactured your first part, right? Again, because we have invested so much into that synthetic engine, we also output the labels, which is a deeply important thing for our customers. Um, and then finally, we do take it all the way to that next step, which is the deployable model. You upload your step file and then get an email back and say, hey, you're ready to run. Again, we can talk about in the comments. We got a lot of examples on our YouTube page. Happy to share those. But for the purpose of this talk, I really wanted to focus in on our synthetic data set and try to help you all build really good SIM pipelines for whatever your applications are. Um, and again, this is a kind of crappy example. I apologize. I was looking for a better one, but it's that domain randomization. In this case, it's an electronics enclosure that's made of ABS, and what you see there is, what are all the different ways that you can get yourself into a bind? It's having slight variations in position, camera angle, and lighting conditions. When you think about those, when you set things up, it leads to a much better outcome downstream. Um, So again, here's that sort of zoomed in and you can see the level of detail. All of these defects are dialed up to like 10,000 so that way you can actually see them for, a GIF. I hope this translates well on the live stream to really get into that detail. But one thing that is incredibly beneficial about using a sim engine for industrials cases is you can actually, for the first time, get agreed upon uh, sign off from your design team to the operations team to the quality team on what exactly a defect is supposed to look like in the defect detection case, right? When we first launched our synthetic data pipeline, our number one customer was they're a systems integrator, and what they were using our generator for was to generate GIFs to show their customers of, hey, your quality inspection manual says that this is the level that is saleable or not. Let me show you a GIF of what that actually translates to. And, the customers would have some crazy criteria like on a part the size of a laptop, thou shalt immediately reject anything with a scratch of like 0.001 mil, like in length, right? Like absolute craziness. And so by having a synthetic set, you didn't actually have to like wait until something was manufactured. You could just actually dial in exactly what that looks like on a call. Um, Save the customer time, saved their end customer time, and they then quickly ran the numbers of like, oh my God, this is crazy. And meant that they were able to launch a product faster, which is all, again, what you really care about when you're building SIM engines or building and manufacturing. Um, Here's that door handle. This is sort of an end to walk through in our case. So this is a part of an automotive component. So on your left, we have our step file. You can sort of walk through what it looks like when you actually have that domain randomized and domain specific background. We took it for this customer. They were incredible. They're a systems integrator. They had a inspection criteria, and so we took a step file and turned around something that was deployable for their RTX GPU in 2 days. That was great. They then went further and deployed to a second line. And we were hitting like 30 frames per second for them, which was great. Absolutely amazing. In injection molding, you're looking at for something this complex, it's like a 42-second cycle time. So at 30 frames per second, we're great. Um, and again, the real value add to industrials customers is being able to have confidence in your reproducibility, right? This is something that comes up a lot in robotics, which is, hey, I kind of have something that maybe works once. All right, congratulations, you're a PhD lab, right? I know I have something that works once in my, works on my machine. It also happens a lot. Being able to prove that you have something that's scalable beyond a bullet and durable across different domains deeply important. And by having that synthetic system really in at your code deployment, because you can say, yes, and so, you know, then we call it Studio. This is our sort of core product that we look at here. Um, all of this is really um, nothing makes me happier than going to a place like Automate, where there's a bunch of you folks, which I get really excited about. I love finding really strong partners who are deeply obsessed with optoelectronic devices. Um, as a person who spent so much of my life, on call, getting weird like slacks of, hey, the robot's broken. I love, taking the software first approach, so that way we can build something that ships forward. And so again, what we call Bucket CAD Studio, I hope you have gained some insights for whatever your specific problems are. Yeah. Um, Looking forward, and taking it to the very start of the talk, um, the CAD model is a fantastic foundation when building in the industrial space. I look at what's happening across the CAD ecosystem. Shout out to Brad at N Topology. They're a brand new CFD tool based out here in New York. Dirac, they take a CAD file and automate work instructions. There's a lot of work that's happening around the industrial applications of CAD space that I get excited for. And as computer vision folks, it's moving further and further to the left and really understanding the whole design process. That's how we as a human species win. Because one of the big reasons that I got into computer vision for manufacturing, and maybe some of you did as well, is again, I've done that job. It's a really boring job. It sucks. Robots exist. If we can use robots at highway speed, we should absolutely have a robot, doing the absolutely dull, boring work of hot dog, not hot dog. So that way humans who are in manufacturing can do the fun, you know, engaging aspects, which is maintaining the robots and really thinking through and building the future that we all need. Um, so that's sort of how I see industrial CV going. Um, but with that, thank you all very much. I hope, sorry, Jimmy, I don't know how much time we have for questions, or if you want to just roll on to the next one. Um, but oh, cool.
All right, so we do have a few questions. I've added two links into the chat. One is the link to Bucket Robotics if you want to learn more about what they're up to. Also, the LinkedIn profile for Matt if you want to connect with him and have conversations offline there as well. let's take two questions. I think they came in early, right around when you were talking about scaling challenges. The first one's kind of a real world example that's kind of interesting. The question is, suppose that a factory is in a commercial door manufacturer where there are high pressure laminate sheets covering the core. These have from a matte to a high gloss finish and a plethora of prints that are requested by the customers. So I guess custom printed doors. What would be the primary training considerations in such a scenario? And I know you talked about the reflective vests, so perhaps this is in the same angle.
Okay, this is actually so much fun. I would actually push on you. The data generation is almost never the hard part for this. It is building a uh, good enough switching mechanism, right? It's the uh, deep challenge that can be integration into your ERP to know that you are using your correct data set and your correct specifically trained model of what am I supposed to look at, right? This comes up a lot in applied computer vision, which is, hey, my defect detector is saying that everything is defective, and then when you go through the root cause, it's, oh, geez, yeah, we're staring at a blue door, and color is a component of defects, and the data set is all red. So, I guess my answer there is the data set isn't really the problem. It's all it's to the right of that that is the challenge there that I would say to really nail down.
All right, so there's a bunch more questions in the queue. I'll let you handle those offline, but let's grab one more. Aside from data visualization tools, what tooling can be used to store and bookkeep your image data through time to ensure lineage clarity? We find this to be crucial in keeping a good overview of which synth data sets work and which don't. So this is kind of, I guess, a data management question.
I was gonna say, yeah, this is. I feel like there's somebody else who's gonna be. That's a set up for some of the other speakers. Um, Honestly, again, my answer there is that it depends tremendously, right? Whether or not you are um, like through the power of cloud computing, it's truly phenomenal. Again, my self-driving brain is so deeply freaked out that I would give you a complicated, well, if you're entirely on the edge. But my answer would be wait for the other speakers. I think somebody's going to answer that shortly.